So for 1a, we are going to use Pythagoras' theorem to find the length of the terminal arm. Now we're given a coordinate and the final coordinate of that terminal arm, and we're going to use that specifically to find the length of that terminal arm. So first I'm just going to move this over and maybe just make it a little bit bigger. Okay, so here we have the coordinates that are 3, 4, right on this end here. So we know the horizontal component is 3 and the vertical component is 4. And if I just draw a line going from that final point right here to the x-axis, and I know that this is a right angle right here. I now have a right angle triangle. And I can label this length here. I can label the horizontal length as 3 and vertical length as 4. In this case it's 3 units and 4 units. And now I want to use this to find the length of the terminal arm. So Pythagoras' theorem is that c squared equals a squared plus b squared. We've probably used it quite a bit, but as a first step I always like to label the triangle that I'm working with. So I'll label this side as c, this side as a, and this side as b. And you know a and b don't matter so much, but it is important that you remember that hypotenuse is always c. So back to our solving here. So we're looking for c squared, so I'm just going to keep that as c squared, and it's equal to a squared, which is 3 squared plus 4 squared. So it is equal to 9 plus 16, and that is 25. So c squared is equal to 25, but we want to find c. That means we need to square root both sides, and we know that c is equal to 5. So this is using Pythagoras' theorem to find the length of the terminal arm. So the same thing would happen for these other questions here, and the only difference is that the triangle would be a little bit different. So if we draw this triangle here, it's still going to be a right angle triangle, but the measurements of it are going to be a little bit different. So the horizontal length is going to be 4, and the vertical length is going to be 3. So even though this coordinate is negative 4, 3, that still means that this length is 4 units away from the 0. But the negative indicates that it's 4 units to the left away from that 0 value. So I'm going to use Pythagoras again. So this is, use a different color, C, A, and B. So C squared equals A squared plus B squared. So C equals square root of 3 squared plus 4 squared. And that's actually the same addition as over here, so it's a square root of 25. And that means that C is equal to 5. So here I just square rooted initially. Just a little shortcut that you can use. A little less writing. And finally, for the last question, this time we're still going to have a right angle triangle, but it's going to be a little upside down compared to the other two. And again, we're still going to use the right angle triangle. Okay, we're still going to use the positive length. So this is going to be 2, and this is going to be 4. And now, when you're using Pythagoras' theorem, it won't really make that much of a difference. So I'll just demonstrate by using the negatives this time. We'll see how those negatives won't really be important in this case. However, when you're going ahead and using it to find the size of the angle, you're going to have to take into consideration those negative signs. So let's use Pythagoras here. So c squared equals a squared plus b squared. C equals square root of, I'm just going to put in the negatives this time, we'll see what will happen, plus negative 2 squared. Now you know negative 4 squared is negative 4 times negative 4, which is 16. It's actually just going to be a positive number. And negative 2 squared is also a positive number, so it's going to be 4 as well. So that means c is equal to the square root of 20. Now the square root of 20 doesn't have a, or 20 isn't a square, so, or a perfect square, so we're going to simplify this radical. If you have c, we know, I'm just going to do this off to the side here. You know that square root of 20 can be rewritten as square root of 4 times 5. Now 4 is a perfect square, and the square root of 4 is 2. So that means I can rewrite this as 2 square root of 5. So this 5 stays in the square root because it can't be simplified anymore, but square root of 4 is 2, so I can bring that out. And that means I can write this radical in simplified form to square root of 5. Okay, and that's it for A, B, and C.